Hello guys, this is Mainak. Welcome all of you to my channel, and today I'm going to design a building in Tekla Structural Designer. I have the soil test report. This is a G+2 residential building, and we're going to design the building full all the way up to the pile cap design in the Tekla Structural Designer software. So stay tuned, and I'll do it step by step. And the plan is created by another architect, and I'm going to do the structural design, and I'm going to show you the process of the design in the Tekla Structural Designer software. And then if possible in another video I'll also show it how to do it using your STAD and RCDC, which I do always. Okay, so let's get started. And if you like my effort in spreading this, just make sure you hit the like button. Okay, so now uh started. So we have this plan, and this is the original plan. And this is, as you can see, this is the ground floor plan, first floor plan, second floor, and the terrace floor. So this is a G+2 building overall. And now I'm going to just make the column positions and then proceed forward. And before that, I'm just going to save this in another file because I don't want to mess around with the original file. Because I'm going to delete a lot of things in the structural drawing. So I'm just going to name this this is plan. This is in inches, so plan feet. This will be some. There will be some changes, and I'll convert it to your for the import in the Tekla Structure Designer. Let's see. So first of all, I'm just going to see this and right click and then select similar and then delete. I don't need the direction for now. Also delete them, and these blocks. Right click, select similar, and let's see. Yeah, I think entire things are selected. Okay, I don't want that. Or you can then just take the dimension, right click, select similar dimensions, delete them. Let's select the window, right click, select similar. Now everything is selected. Select this, right click, and select similar. Now, yeah, good. So yeah, we have deleted most of the things. Select this, right click, select similar. So I'm showing you the entire steps how we get a fresh plan, and you to have to work everything. So the main motto here is I want to just place the column. So anything which is not needed, and I'm just deleting those things for showing the uh, process correctly. Okay. So these are the two staircases, and okay, these are the two staircases. There's a balcony here, and we have water tanks here, right? And we have a sofa place and a balcony in the what seems to be the terrace floor. Pretty good. Okay, so yeah, this is the arrangement here. And, yeah, it's pretty nice plan made by the architect. Have to say that because I see a lot of plan, and this is a very nice plan. Obviously, plans have to be customized as per the client. So their involvement is also there. It's a very good looking plan, to be honest. So this is done, and you can see this portion. This portion in the next floor, you can see this. So we'll take everything into consideration, and then we'll do it. For now, we'll just see compare the ground from the first floor, and then make the arrangement. So I'll just save this file for now, and I'll convert the file in what works best in Tekla Structural Designer. I think it's So I'm just going to go in Tekla Structural Designer, click on new here. And by the way, you can get Tekla Structural Design education version if you're a student still studying. You can easily get that. So check that out in the official Tekla Structural designer website, Trimble website. Okay, have clicked on new, and just I will just model, or rather just go to the model and go to construction levels and create levels. I'll insert level below, and this will be let's say length is 1.4 and foundation depth is 1.5, so minus 1.9, and I'll keep this as 0, and I'll insert one above it, and the spacing will be, let's say, 3 meters for now. Okay, this will be SSL structural slab level, and slab value. I think this is a pretty 150 zone 5 earthquake. So G plus, this is only G plus 1, G plus 2 building, and I think we are good here. Click on OK. So my this modeling, this part is ready. I just will prepare this. So new AutoCAD file F7. I have to turn off the grids. Just layering the units here. UN enter precision triple, and I want this, sorry, precision of 0 and millimeters. Okay, I just print working millimeters. Can I get precision of 0? Okay, I'll go to annotate and set the text. Next, I'll just go the 100 scale, default scale of T100, and let's go with Times New Roman here, and then text height of 150, and then just click on apply and set current. Okay, and then close this. And then dimensions also by default, we'll just create a new dimension here, and uh, just click on continue, and we'll just set the primary units precision 0, and the text which we had created, like with dimension line, arrow size same as the text height, and click on OK and set current. So my text setting is done, and now I'm just going to select this and copy. I'm going to go to clipboard and then copy, and then go to drawing and right click, and then clipboard, and then paste. Just paste around this one, right? Okay. So here you go. We have the entire drawing pasted here, and now we're going to scale this. So you can see it. This is in feet and inches. So you'll see the dimension, and then definitely try to scale the thing. So the wall dimension is 5 inches, and if you just convert the 5 inches it properly, it will 5 into 25.4 mm. This is 127 mm to be exact. So here I'm just going to click line here. Just take a line and turn on the ortho and do 127 mm line. Okay. So this line, you can see this is a 127 line. So I'm going to select this, all of this, and AL enter, and take the first source point as this one, first source point, second source point as this one, second source point, hit enter, and yes. So my uh, this thing is done, alignment is done, and now you can check also to cross verify whether it has been converted correctly or not. Just see and see the conversion, and just check the full dimension of this in the original plan. And this is 70 feet 6 inches. 70 feet 6 inches means 70.5 feet, sorry, 70.5 into 3.28. This will be in meters. So it will be 231.24 meters, which is 231,240 mm. So if you just see this, sorry, not, okay, I did a mistake here. Say 70.6, this silly mistake. So 70.5 divided by 3.28, not multiply, it will be 21.493. So 21493 like this, or 494. So go to the original plan and then just check the dimension. So it is 21. It should be 488. It is 493. So it is pretty much accurate here. 70.6, 70 feet 6 inches, and this is 70.5 divided by 3.28. So it is pretty much close, as you can see. It is converted correctly. So there will be a minimum fraction of error, and that's acceptable. Okay. So we have converted the plan successfully, and this plan, we just will name this as plan mm with column positions. Okay, so you name it this, and then just click on save. So this is ready for now, and you can see I'll just move the plan a little bit here up, up to 0 line, and we're just going to fit the columns. So I'm just going to create some sort of blocks here so that we are useful with it. So first of all, I'll just select all of them and make them in the 0 layer. So once we have everything in the 0 layer, and also layer 0 and by layer. So once we have everything in the 0 layer, then we use the command ladle, because suppose we need to import anything, then we need to get rid of the unnecessary layers, delete layer, and we are with 2 layers which are default. Now layer properties, and we create a new layer and we call it our beloved columns. Uh, MNS, and just going to take red color and close. Okay, so we'll select the layer of columns, and then we'll select the rectangle, and then left click anywhere, and then at the rate. So you go with the, let's go with 350 to 50 columns, 350 comma. Uh, Sorry again to do some mistake. Left click, and then at the rate 350 comma 350, enter, and then I can hatch it as well. HA enter, and then just hatch this, and then select this, copy, and then simply do this. Okay, and then we'll just put it at the points which we need, right? So before that, I can also select, just check, cross check by overlapping. So I'll just copy this and go take this above, and just make this into block and name this as FF, the first floor, short form, and no, this should be in zero layer. Yeah. And then we'll just copy it here. So the staircase, this staircase is common, so this will have a common point. So I'm taking this as a reference because I don't know whether the architect has extended this or not. Okay. So when I click, if there is selection, there is the first floor. If there is no selection, that is the ground floor. So I can easily see the overlap and all, and I have to place the column positions accordingly. So these practical structures you might not see in any YouTube videos. So all this I cover in my course and my also my YouTube videos which I make, so that you guys can have a practical understanding of the real work scenarios. Okay, because in the real work you'll not find many symmetrical structures. We find this kind or more complicated than that. In my experience, I work at many structures, and this architect has pulled up a good work. I think you can see most of the beams are symmetrical here. There is a ground floor and the first floor beams overlapping, but you will not find that in most of the work. So you have to find a way to work around that. So that's why if you are really just going to learn structural design, or just pursue this as a career, so you should practice this kind of plans. And the more work you do, see, I'm the point I am copying. The more work you do, the better you will get at it. Okay, and so yeah, this is the thing. And then okay, then we will need another layer of columns, and take this column and this column, and let's say, okay, let's skip it at the end. Let's skip it at the end here for this, and copy this and take this to the end. Okay, so let me see the first floor or ground floor. First floor will be selected by this. So there is no beam here in the first floor apparently, but yeah, first floor this beam is there. So I think this is in line with this. So I'm pretty much okay with this. So select this again, this line. Want to extend it further. And I'm just thinking whether there is a requirement of this particular column, but I'll go with it, right? I'll go with it because, yeah, just go with it because I don't want very heavy columns, very heavy beams in the front. So if I keep close columns, then I will eventually get, lesser size of beams. I'll get more beams here, there's more deeper beams here because I haven't given any columns. If I just divide this, then I can also negate that as well. But the reason I won't do that is I have to give columns here which are very close. This distance is around 5 feet apparently, but I have to give because the building ends here, right? Building ends here. This portion is the ground floor, and this portion, the first floor, you can see it ends here. So obviously, I need to give columns here. And regarding the depth of the beam, I think this we could use more columns, but let's see. That is too large, then we'll introduce a couple of columns here and couple of columns here, and the uh, structure will be reduced. Let's see the what is the distance here. So it is 6.5 meters. 6.5 meters is around 21 feet. So it will be pretty deep beams here. Okay. Okay, let's go with it for now. And let's see the ground front first floor orientation also. This is the first floor beam, first floor beam. Yeah, so it is secondary beams are also going to rest in this. So it is just going to be deeper beam. So if possible, then we can, I think we can give columns here. Okay. Okay, let's move with this and then we'll decide later. So this is our uh, ground floor, you can say the ground floor column position, and it's verified by overlapping the first floor. You can delete the first floor overlap now. This is verified by just achieving by overlapping with the first floor. And now I think we can do the column position, column center line for the import in the Tekla Structural Designer software. So we'll for keeping I can just import this and also add the secondary beams in the next floor also, and add the secondary beams in the next floor also, this floor also. So you have to work around with that, but for keeping it simple, I'm just going to do the primary beams and also the secondary beams with the ground floor. So the building is not that simple. As you can see, there are different floor positions in the ground floor and the first floor, but only for keeping it simple, I'm going to do this in the plan. So just to make the video quick, okay. And in the later I'll also show you, if possible, then how to do the remaining things as well. Okay. So making the center line here for this, let's proceed forward. Okay. So I just want to make the center line for ground floor first. So I'm just going to go right click and I'm just going to save as, and center line for ground floor or 10th level PL. Okay. So I'm going to save this. And when I'm going to make the center line for PL, I don't want any additional things in my things. Okay. So I just going to take a line here and first point 0, 0, enter, and then just drag it. Just I want to know what is the exact center point so that I can overlap here. So this and copy and just join this. Not copy, I should have what should I have done? I should have moved it, right? Moved it at the origin point, right? So columns at the origin uh, have been moved, and now I'm just going to delete the stuff which are not structural parts. Okay, don't want to confuse the within the Tekla. So TR enter, and then F enter. So yeah, this is done. And then you can delete this now, and then select this, and these we have two layers, right? So I'm just going to create a new layer here, and this will be called our center line CL, and I'm just going to take this layer as this 252 color, and then just click it again, it will close, and I'm just going to take this CL1 and take a line here, and let's just give it at the center, escape, and then click it. Right? This first center line is created, the longitudinal center line, and then we just go to paste it like this. Okay, another center line, let's create. Copy. Copy. So this is done, and when this is done, So we have the majority of the things here, and looks like now we can import this. So this one plus control plus S here for the plinth level, control plus S, and then go DXF OUT, DXF out, and this it will be center line for PL, DXF, and just save this. So once this is saved, now we can go to the Tekla Structural Designer and make sure with the plinth level, you go to structure and see the levels. So the plinth level is this one, structure base, and then right click and then import DXF. And yeah, we just need to go to the location. So I have opened the location, select the file and then open. And then just we'll just import the center line. As our picture grid, the unit will be and click on next, and it will be in these two layers. I got this in the plinth beam and the next layer, and in the remaining ones, we'll try importing. Let's see if it works, or otherwise we'll do anything. And by layer and click on finish, and it automatically pops up as you can see here. So here we'll just right click and sorry this and select the same file, and this time select the remaining things except the center line as a shadow, as obviously the unit will be finish, and just use your mouse to drag this shadow up and zoom in. So yeah, once this is done, just you have the plan imported, and you can easily just use this to make the drawings. Now, first of all, we're just going to go with the columns here. Go with the column, and by the whatever the default country settings you need to do, and my default setting is to India. So this is done. So column size, I just want to edit this and do this 3350 into 350, and select your steel grade. I'll select FP 550. Okay, let's go FP 500 for this one. Okay, and 40 cover, and then concrete grade is M20. We're going to select this, and this automatic alignment, just turn it off, and then place the columns. Layer by layer, I will just do. There is no intersection here, so we're going to fix that later. Let's place the column switch. So let's just save this automatically and off, and save this as C350 cross 350. I'm just going to select this again. Okay. So you can just select this anytime you want to enter the value, right? For these columns which don't have the intersection, I'm just going to delete, select, and control select and delete this two. Okay. And then we're just going to select the center line. So let's see the distance. We have to do some sort of immediate work. I actually, you can see here, I forgot to make the center line, vertical center line of these two. So I'll do it now. And I'll see the distance between these two, and should be good to go. Distance between this to this is 6350, and distance between this to this is no, 4394. So 6350 first. So here grid line parallel quick. Select this, and this will be 6.35. Okay, click F2 and then write 6.35, enter, and then the total distance, if I enter the total distance better, add it anyway, but it is 10.774. So it is click F2 and then 10.77. Sorry, what was that? It is forgot. It's 774 or something else. 10.74. Sorry, it is 10.2, and then click here and 10.744. Enter. So it's just going to create this, the wrong one which is made. So grid line one item, it is a pixel grid one items, and just select this particular line I just want to select. So deleted. So one item has been deleted. So now we can easily place the columns. Click on the column once again and take the CV 350 to 350, which we have done. And this page is turn off the automatic alignment. Then just do this. Okay, so we are done with all the columns. So when you're done with all the columns, just click on escape, go to structure 3D, and you can see the columns are pretty much ready in position. And now you want the plane beams, okay, to be executed. So if you have any secondary beams, make those beams first. Click on beam, and here we use to click even some secondary beams here, 250 into 350, and just going to give the secondary beams first. And you can see I have not created any grid lines for the secondary beams. So it's better if you create the grid lines and then make the secondary beams. Okay, so that you can just assign this properly. Okay, so just going to show this how to make a secondary beam here. Do it like this. Okay, this will not work, but what will work is suppose you just select this and parallel quick, and then place it along. I'm just going to place approximately along the center here, and take the beam here like this, and then you can simply just add the secondary beam, single click, and then double click here. So the secondary beam is added here like this, and you need to double click it, and then go to releases, and then this both end will be pinned because they don't have any column to column connections. So this is how you make those secondary beams. Okay, I'm just going to select this parallel quick, and you can do it in the AutoCAD itself, so that it is quicker. Okay, so here beam, and select this and drag and double select at this point, and escape, double select this, releases, pinned, and pinned. Okay, so like this, the major secondary beams you can give, and after these are completed, then you can go for beam, and we can just define a beam here, M22, 2350. Everything is done. Just select this like this. All the major beams are selected, as you can see. Click on escape, and then just click on validate. If there is no overlap, it will show there is no overlap as of now, and you can see the structure 3D plane beams are ready. So the plane beams are ready now. Okay, as you can see. So for the first floor, I told you that we will stick with the same plan, but let's see if we make the this center line of the first floor, and does it work or does it not work? If it doesn't work, then we'll continue the same method. Okay, because I had tried it another time that didn't work properly. Okay, so center line for PL, I think we can just delete, sorry, close that, saving the changes, and then we'll going to go to the CAD file, that is the center line with column positions. So we have this now. So first of all, we're just going to save this file, and I'm just going to do this save as for now. Save as, and this will be center line for this will be first to ground floor slab level. So just let GSL, let me just call it GSL, or let's simply call it first floor and save. And when we save this, and then we can delete other things which we don't need, that is the other floor plans. Okay, just this is an experiment just to see whether importing multiple layer or works in this Tekla Structural Designer or not. Okay, so yeah, this time I'll just do the secondary beams as well, just to make sure and give you a complete vision of the things, and if it works, then it's good for us, right? So yeah, no secondary beam here, right? Yeah, that is pretty much this, and I don't think we don't need any closed beams for this one. Let's give this short. Okay, let's ignore. Okay, let's give this as well. Why skip anything? Yeah, secondary beams, all secondary beams are done here. And obviously for the balcony part, if you want to put balcony, in particular, so for the balcony part also, just to go select this and move it to the balcony. Okay. Yes. Now we are good in terms of this, and now we'll try our method of line 0, comma 0, enter, and then just moving the columns in the same spot. Okay. And we delete the line now. So the column is at the same spot now. Control plus S, save this. And then we'll just use the command key except OUT, takes about, and then send line for first and save this. Let's see if this import works in the Tekla Structural Designer or it has any errors, or else we'll continue with the same plan for the sake of this video. Just go to the next floor. For this, go to structure menu, structure one, that is the first floor. Columns are already there, import TXF and import centerline for FF, open. And by the centerline only, we'll just know whether we are okay. Unit is in mm, and click on next, and only for this one, let's see, finish. Let us check. Yeah, it didn't work. So as you can see, this import, even if I placed it at the same location, it kind of didn't work. Okay, so it has been shifted a bit. So I can move it, and all I can do all those things when, and I can just move these grid to the center line. You can try doing that, but uh, let's see, edit and move. So I can try moving this. Actually can work, but just now for the sake of not wasting your time, let's just continue with the same plan. And in practical, I can still make this work, but I have to import the same, center line as the ground floor and then make it work. Okay. So just go to model and then import the center line, import the Excel for the plinth level as well. Okay. For the center line and center line only, and then import it in and then next, and in all the remaining layers, I'll just do it. Okay. So yeah, I'll just do this one, and we'll go with the same plan here. So for going the same plan, you can just copy this. So go to construction levels and just make this file as base and click on OK. So the same plan will be copied. Okay. in practical, if you want, if I, when I work on the project, if I want to work on different plan, then I need to, use the center lines and copy those center lines and see the distances from the CAD. Like, I just I did a, just a couple of minutes ago. So then I need to make the center lines and then I need to make the second image. So I have to do that. So that takes some time. So just for the sake of video, we'll just going to make this symmetrical. And I'm just going to put slabs here. And there is a staircase here and there is a staircase here. So avoiding these two portions in all the remaining positions, I'll just make the staircase. I won't bother if it's a one-way or two-way because I'm not going to design slabs here. And anyways, two-way slabs are not designed in this software. Okay, only one-way slabs are not designed, only two-way are designed. So no issues in that. In structure 3D. And I'm just going to copy this level here, construction levels here, and make this as unique. And click on OK first, because the base is this. I don't want to get copied here. Okay, I should have not done this. Just while clicking, I should have clicked unique first and then done it. So no problem. I can delete it now that it is unique. So now go to construction levels and make this as your one, and this one also as one, and then click on OK. And then this go to construction levels and make them back as unique. Click on OK. And actually, if you just see the original plan, if you just check out the original plan here, which is the original plan. So in this floor, that is, it is only this staircase is only in the first floor, and in the second floor, this staircase is not there. You can see this. So we can fix that. So in the structure, go to structure 2, and here we'll just put the slab here. So in go to structure 3 and put the slab here as well. So only this staircase is there for the next two levels. So we are good. Overall, the main frame has been created. Some differences are there with the original structure in terms of the secondary beams, but that's okay. Just for the sake of making this video. And then one important thing which you need to do is you need to make all your connections as fixed. So just select all your connections, supports, and make them as fixed. Right. So once this is fixed, so your modeling part is about to get completed. Before that, you need to define your headroom level. So go to construction levels and insert above, and we'll take a height of, let's say, 2.8 meters for our headroom. Click on OK, select the columns which have the staircase, one, control, and select the remaining columns, and make the top level as the highest one. Right. And once you have done it, go to the highest level, double click, and okay, I've just done one column wrong here. As you can see that, okay, I correct that. So just select this column, make the top level as 3. Okay, and this one, make the top level as 4. Okay, so now go to the floor. Now you're okay. Select the beam and then the beam here and the headroom. So now you can see the modeling part of the structure has been completed, and now we can go for the loadings. So I made a lot of videos on how to just define the loads. I'm just going to go with it and just assign the loads. Okay, structure base, and what is it here? Structure base, and go to load. So the logic behind how these values I've already explained. If you want another video, I'll make, or you can just check out my videos on explanation of dead load, live load, quick load, etc. Okay. Here we'll just take full UDL, and this is a 5-inch wall, so going at 7 kilonewton. I will select all individual walls for assigning the wall load. This option is better in STAD, where and also in ETABS, where you can just select all the walls comfortably. Okay, so this is done here, and I just want to go to the next floor and you just take the dead load and pull UDL 7, obviously, and sign them. Check out in 3D. So you just I'm just making sure that I'm not just selected any load twice. Okay. So yeah, we are good with this loading and just validate the model to be sure that the loading on this floor is done. And I'm just going to go to post loads and like on the level load of 2 for the residential one and then just provided. And then just I cannot select the similar level because this level is different. Okay. This level doesn't have any one of the staircases. So I have to just assign it again. So go to the structure 2 here. And this time I'm just going to, for easier just things, I'll just slab openings, not slab openings, slab panels. I'll just turn it off just to make it, just look easier. So yeah, we have this slab items. Okay, this is not turning off at this point. Let's see. It is not turning off. Okay, I'll just continue with it. Okay. Dead load, full UDL, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. You can go to live, imposed, level load, 2, done. And then and the next floor I can copy this load. So go to structure 3D, just to enter the view that load here. And yeah, I can copy this to the next floor. No, I cannot copy because next floor will have parapet walls and the loading is different again. Structure 3, and in the structure 3, we'll have dead load and full UDL of 7 around the headroom. So 1, 2, 3 at 4. And 3 for the parapet walls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. This is done. And then we'll go imposed loads, imposed, and in imposed, there this will be level load of 2. You can just give it, or you can skip this one as well because this is the terrace, but I'll just give it. And then we'll go to home, structure 3D. You can see the loads here, dead load and imposed load applied. You can just check for this, check, you can just see this. and this is the structure, and the load has been applied here. And then we'll just go to model and validate the model, because I have to make sure everything is okay. And then I'm going to go to load, and then I'm just going to apply the earthquake load, seismic wizard. This building is in zone 5. Ignore seismic below the base level, and zone 5. And this is the type 2 soil, and important factor 1, because it's a residential building as per this Indian code. Damping 5% is okay. Zone zone factor it takes automatically, so no need to change that, right? And then I'll use the model response spectrum analysis, and moment resisting frame, and RC moment resisting frame without any uh, buildings. And then this is a movement frame system and special movement frame for the ductile design, right? And then click on 5, and then we'll take all these dead and live loads into consideration. Next, and skip this check. Okay, then finish. And then we can just click on operating, and then next, and then finish this. So once this is done, we can go to load, and we can just select here uh, the load combinations which we need to give. Okay, so load combinations, and we're just going to click on generate, and yeah, next, 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 and then finish, and then click on OK. And then we just going to click on validate whether everything is okay or not. Everything is okay. Then we're going to go to design, and design all static. So it will take some time depending upon your system speed. And the superstructure should be designed in any member is failing. I think some beams will do fail. It will show. So these some are showing warning, some are fail, but for actual review, we're just going to select this ratio, and you can see all the red members are failing. So actually no member is failing, as beams are failing, as you can see. So anyway, we have to increase the depth of the beams here. So we just going to control select all the beam design groups here, and then I just going to increase the size here, and you can increase it individually. But I'm just taking making this video, I'm just showing you. So I'm just going to give it a size of 300 into 450, and just going to click on OK. And then I'm just right click, and then design. We have an option of design selection here, static. Let's use this option. And then after this is done, just make the ratio once again. And I can see all the beams have been passed. You can just check the design of one particular column, design member, object number, static. And this is 816. So column reinforcement is pretty cool. And just take this beam, for example, and check member, and it is 316 and 316 in this span, 363 in this span. So the design is pretty much clean here. Okay. So design of beams and columns is done. And after this design is done, we just going to do for the foundation. So for the foundation, just take the plinth level, the soil test report. So I just want to save this file. It's a huge file. If this anyway goes away, then it will be of loss. So G plus 2 building. Okay. Just going to rename this, right? And save this in the folder. Otherwise, it's all the memory will be in the cloud, right? So here I'm going to go with the I'll show you the soil test report first for this particular project. Okay, this the last time just was the bits and pieces of this report. I think this is page 22. Yeah, they've given the file diameter size. I'm going to go to 500 dia file, and all these values are here. So I'm just going to insert it. So I'm just going to go foundations, and then catalog, and then add, and then here name I'm going to give 500 dia, installation, it will be this is a cast in situ, so it will be poured, and shape is circular, diameter 500 length, as you can see in the soil test report. Length is 10 meter, okay, 10 meter from the this ground floor. So, and load transferring, and it will be friction plus end bearing. So I'm just going to go with the friction here. And the material concrete, obviously, minimum used to use F25 concrete. Pile capacity, axial, tensile, and lateral. So these values, except from the soil test report, just cannot find it. Lateral value is 104.81. So I'm just going to 104.81, same value I'm just going to take. Tensile and compressive. So compressor is 698.72. So I'm just going to get 698.72 here. And for the tensile resistance, and tensile resistance is the uplift. So it is 363.33. 363.33. I have a thumb rule. If you have only the one resistance, the compressive one, make the tensile as half, and make the lateral as half of it. So you can easily get value. This value are by chance not given in the soil test report. Okay, but if you test from a good company, all the values are given. Okay, so these things you can just ignore and click on OK. And yeah, I just click on OK for now. Soil test report gave me these values. So these are done. Now I'll go here, while gap column, and I'm select this all, and you can see by default one file is there, but depending on the load of the column, it will design. So design pad faces, and so not design file cap. I've given the wrong option. So it has design. So it is one file and two file here, but I'm just going to go to settings here and foundation files, and minimum number of files under column. As per our code, it is 3. So I'm just going to click on OK, and then design file caps will be just 2. It will keep the same, but now I can delete this. Right click and select all and delete this first. So I click on OK, and then uh, file cap column, and then assign this, and then design file caps. Now it has been given our 3 files. Okay, so if I give 2, then it would give 2 as it would be safe in 2 as well. It is not much load. So if in some codes and in some places, if the 2 file is acceptable, for example, so we can give the minimum number of files and columns as 2. Okay, and then click on OK, and then just go here, file cap column, and then just design file caps. So then obviously it will give 2, for each. So there is not much load, and the capacity of files which is used is good. So 2 file caps for all the columns, and the file in the columns has been designed. And now obviously you can get all the drawings here. You know that, go to drawings, and I'll go to the foundation level here. Okay, so the foundation level is, have to go to the structure window and go to this base level, and then here I can just select on the column schedule, and obviously all the column schedule I'll just get here, and then click on OK, and then I'm just going to give it a name here in this file, the saving code. Okay, and I'll show you the drawing as well. This is the column schedule. So now you know the all the columns details here is there, along with the VBS calculation. Okay, and then after this you can get the general arrangement, which will show you the column locations. So maximize this. So this is CRC1, and from the previous drawing you can just check the details of CRC1. It's 816, 350. You got the general arrangement, you got the column location, and then you can get the foundation reactions as well, foundation layout as well. Just click on the foundation layout, click on OK, and you'll get the foundation layout. You can see the pile cap layout here, and the pile cap layout with details, and also the pile cap details, depth, length, everything you are getting here. And similarly, you can if you just go to, let's say, the plinth level, and then you can just select on the beam schedule, and select the beam schedule for the plinth level. Just click on it. You can see the maximum reinforcement in the bottom is 360. In the top is, you can see This is, you know, all the bars which are being used are, it's showing here. You see 316 and 6 number of 25. So this 2 number of 20. So all the bars are, showing here. You can take the maximum of this top bars and the maximum of this bottom bars, whichever it is showing. You can use this for the beam layout and beam schedule you find out, and beam layout if you want. For that you have to go the general arrangement, and here in the general arrangement you find the names of the beams. Suppose this name of the beam is base B71, and here in this base B7, B6, B CRB71. Then if we find this beam like this. So CRB71 and base B61, B71. So all these beams you can find it here. Base B2, B52. This is base B71, base B72. So all these beams you can find in the schedule. So schedule and layout, everything you find here. There are a lot of other things as well. I'm just showing you a thing briefly. So the complete building design is this much. And if you found anything useful, make sure you share and keep learning and keep growing. Thank you. Bye-bye.